Okay, if you missed yesterday's lesson or you want to rewatch what we did, multiply and divide monomials. Before we get into that, that is lesson 1-3. Before we get into that, though, we have to look at something that happened as I looked at your homework data. Many of you didn't know how to evaluate the expression if A was 3 and B was 5. All you do is plug 3 in for A, that'd be 3 squared. 5 in for B, that'd be 5 to the 4th power. And so it'd be 3 times 3 plus 5 times 5 times 5 times 5. That'd be 9 plus 625 be 634. So we had some problems with that. And again, pause, look at it if you need to. Number 6, take a moment to do this on your own. Again, you should pause it if that's not enough time, which I'm sure it wasn't. 3 minus 5 is -2. -2 squared is 4. 3 minus 5, -2. -2 times -2 is 4. Make sure you do everything in parentheses. When the square is outside the parentheses, you do everything first, then you multiply, then you use the exponent for whatever's inside. Here's another one. Solve the problem, type the numerical answer. Again, you can't type it. But g to the 5th minus h cubed. And the answer would be, sorry, I'm doing these in my head, 243 minus 16, so it'd be 227. If C is 8 and D is -3, that would be 64 plus -3. -3 times -3 times -3. -3 to the 3rd power. -3 times -3 is +9. 9 times -3 would be -27. 64 minus 27 would be 37. So the answer on this one's 37. Place a red dot. Well, you can't do that. One of these answers is 10, and one of these answers is 16. So go ahead and do the work. And I will tell you that the one on the left is 16. The one on the right is, in fact, 10. And if you didn't get those answers, go back, try it again, see what happened. 1/2 squared, by the way, is 1/2 times 1/2 is 4. 1/4, I'm sorry, 1/4. And 2 to the 6th power would be 2, 4, 8, 16, 32, 64. And 1/4 times 64, 1/4 of 64 is, in fact, 16. Okay, now to go with today's lesson. Know and apply the properties of energy exponents to generate equivalent numerical expressions. What is 2 squared times 2 squared equal? Hopefully you came up with 4 times 4, and you got 16. What is 2 squared times 2 to the 3rd equal? Well, 2 squared is 4. 2 to the 3rd is 8. 4 times 8 would be 32. How about 2 cubed times 2 cubed? 2 to the 3rd times 2 to the 3rd. 8 times 8 be 64. Okay, here it is. 16, 32, and 64. What power of 2 is 16? And the way you can figure this out is 2 times 2 is 4. That's 2 to the 2nd power. 4 times 2 is 8. That's 2 to the 3rd power. I'm actually using my fingers to do this. And 8 times 2 is 16. So you can do powers of 2 by using your fingers. Real simple. 2, 4, 8, 16. So what power of 2 is 16? It's 2 to the 4th power. What power of 2 is 32? Well, again, 2, use your fingers, count. 2, 4, 8, 16, 32. Hopefully you came up with 2 to the 5th. What power of 2 is 64? 2, 4, 8, 16, 32, 64. You got back to your index finger. Now it's 2 to the 6th power. So 2 squared times 2 squared equals 4 times 4 equals 16, 2 to the 4th. This one, 32, is 2 to the 5th. And finally, 64 is 2 to the 6th. take a look at those right there. And again, if you were doing this on a pair deck, you would tell me, what do you see about those? What do you notice? And hopefully what you notice is 2 squared times 2 squared is 2 to the 4th. 2 squared times 2 cubes 2 to the 5th. And you say, hopefully you've noticed you're taking those exponents and adding them. If you have the same base, 2 is your base, 2 is your base, 2 is your base. If you have the same base and you have exponents, you just add the exponents. This is 2 to the 2 plus 2, which is 2 to the 4th. This would be 2 to the 2 plus 3, which is 2 to the 5th. Works that way for every number. To multiply powers with the same base, it has to have the same base. Has to. They give you an example here. 2 to the 4th times 2 to the 3rd. 2 to the 4 plus 3 equals 2 to the 7th. Algebra, you don't need a number as long as the base is the same. A and A is the base. A to the M times A to the N. We don't know what M and N, we don't know what A are, but we can write it as A, M plus N. A to the M plus N. Here's another one they give you. 3 squared times 3 to the 4th. Now they actually write them out so you see. You know that if you have 3 times 3, you got 3 to the 2nd power. If you have 3 times 3 times 3 times 3, you know you have 3 to the 4th power. They're just pointing out to you that all you're doing here, if you want to know why the adding works, all you're doing is taking 3 times 3 times 3 times. And if you end up counting, it'd be 3 to the 6th power. So that's why it happens. So you can either accept it does or understand why. Whichever way, you'll get there. The base must be the same for this to work. I want to make sure to point that out to you. You can't have 3 to the 2nd power times 4 to the 3rd. It doesn't work that way. The base has to be the same. Okay, do these problems. A would be 9 to the 5th. Again, pause me if you're not there. A is 9 to the 5th. B is A to the 5th. C would be -2 times -8, which is 16. Positive 16, M to the 6th. Positive 16, M to the 6th. That'd be M to the 1st power times N to the 5th power would be M to the 6th. Okay, dividing. If multiplying, you add the exponents, you probably can figure out that dividing them, as long as the base is the same, you're going to subtract the exponents. So the example they give you, 3 to the 7th divided by 3 to the 3rd, be 3 to the 7 minus 3 or 3 to the 4th. And in algebra, again, A to the M over A to the N would be A M to the M minus N power. A cannot be 0 because the denominator can never be 0. And once again, they give you numbers down here to see. 5 to the 7th, you got 7 5s. 5 to the 4th, you got 4 5s. And they show you how they cancel out, which is just like subtraction, and it leaves you 5 to the 3rd. Okay, I want you to compare these two. And again, if we were doing the pair deck, I'd have you take 2 minutes to look. What are some of the similarities and some differences that you see between these two? Hopefully some similarities you see was you have to have the same base. That the exponents you're either going to, well, the differences would be the power, the product, you would go ahead and add the exponents. And for the quotient, the dividing, you go ahead and subtract. Those are the similarities and differences. Here we go. Again, pause. I'm going to go through it. This be 5 to the 3rd, 7 minus 4. X to the 10 minus 3, which would be 7. Ooh, we got a number here. 12 divided by 2, so that would be 6. W to the 5th power, W to the 1st power. Don't forget the 1s there, even though we don't put it. That'd be 6W to the 4th power. This one looks hard. It's not. Take it one at a time. You got to find the same base. The 3s are the same. So that would be 3 to the 2nd power times 5 times 7 to the 5th minus 7 to the 3rd be 7 squared. So that ends up being 9 times 5 times 49. I think 2205, if I remember doing this last night. I think that's what it came out to be. Again, look for the same base, and you can go ahead and all you're doing is simplifying this fraction. If you multiply it out exactly how you saw it, the numerator, multiply it out the denominator exactly how you see it, you would be able to simplify it back down to what we're just making it easier by simplifying it earlier. That'd be 5 squared times 7 squared times 8. 5 squared times 7 squared times 8. Negative 2 divided by negative 2 is 1. So this be 1 to the third power. 5 minus 2 be third power. I did that wrong. I'm sorry. Negative 2 to the third power. That'd be negative 2 to the third power. My apologies. 3 to the fourth divided by 3 be 3 to the third power. 5 to the seventh divided by 5 to the fourth be 5 to the third. One more time. Negative 2 to the third times 3 to the third times 5 to the third. And then click on the practice slide, which is in your Google Classroom, to practice. There's a practice page for you, 12 problems to get done. Please turn that in as an assignment. Thank you and have a good day.